Chem Ch, let's finish up this worksheet with number 7. Nitrogen and oxygen combine to form several compounds, which is true, as shown in the following table. Now what we see in this table is we see these 3 different compounds, all different forms of nitrogen and oxygen. And in this next column over here, mass of nitrogen that combines with 1 gram of oxygen. Now, we're not using the mass, the periodic table mass of nitrogen or oxygen. We're not looking at the mass of one atom of nitrogen or oxygen. What we're doing is, if we only had 1 gram of oxygen, only 1 gram of oxygen, okay, we're not really caring how many atoms that is, how many moles that is, whatever, it's just 1 gram of oxygen. What's the ratio of nitrogen that would combine with that 1 gram of oxygen? Okay, now in nitrogen monoxide, okay, 1.7 grams of nitrogen per 1 gram of oxygen. When we go to nitrogen dioxide, see the ratio of oxygen to nitrogen has gotten larger. Okay, so there's less nitrogen by comparison. And then when we go down to NO4, okay, again, there's even more oxygen compared to the nitrogen, so the ratio of nitrogen to oxygen is now less. Okay, less nitrogen present, relatively. So what we're actually supposed to do with this data, calculate the ratio of the masses of nitrogen in each of the following. Now, we have this data, see, mass of nitrogen. Okay, calculate the ratio of the masses of nitrogen. We're getting that from this table right here. And so functionally what we're going to do is we're going to compare nitrogen monoxide, nitrogen dioxide. So the ratios, 1.07 and then 0.85. What does that equal? Well, use that trusty calculator. 1.70 divided by 0.85. That ratio is 2. Oop. It's off the screen a little bit. Yeah, but again, when we talk about the law of multiple proportions, and I'm hoping you've already recognized that this is going to be talking about the law of multiple proportions, because what do we see? Proportions, how many of them are there? Multiple. Okay, more than one compound here. Okay, let's look at B. NO2 to NO4. Okay, NO2, 0.85. NO4, 0.44. We can do that. That'll end up being 2. Okay, so that's just fine. And then lastly, we'll do 1.70 to 0.44. And you guessed it, this will end up being 4. Yeah, I know that these don't end up looking in the calculator like those exact round numbers, but I do want to point out, and this will be something that we use later in the course, they're incredibly close. And so if we were to actually use the number of significant figures that we really would have access to, okay, several digits out here, these numbers would get closer and closer to these the small whole number ratios. So for now, don't worry about this too much. Realize if we had more exact measurements, this would get closer and closer and closer to 4. So if you notice that and you say, oh, that's not exactly 4, that's true, but realize these aren't the most perfect measurements to use here. We're just trying to illustrate the law of multiple proportions. When we compare the mass of each species to however much mass comes from the element from another species, we're always going to get a whole number.